This is lesson 9.2, logarithmic functions in trigonometry, and hopefully you've had some experience with logarithms in past classes, so this should be pretty much review. And what we're doing here with logarithms especially is when we have something to a power that is a variable. So if we have 3 to the x power equals 9, what we're doing is we're trying to find out what that exponent is. So a logarithm is actually an exponent. And what we're doing first of all is kind of coming up with some of the language we use dealing with logarithms. And when we have something that's written like y equals this, that is read the logarithm to the base a of x. So y equals the log base a of x. Alright, so by definition, this is the bottom of page 402. By definition, the logarithm that I have there, the power to which a must be raised to obtain x is y. Or, if we're going to write this in exponential form, what you're used to, x equals a to the y power. So see, we're trying to find that exponent there, and that's what that is. So, for example, let's put some numbers on here. So if I have 2 to the cubed equals 8, that's called exponential form, and if I'm going to write it in logarithmic form, I'm going to write it as logarithm base 2 of 8 equals 3. So what that says is, what exponent do I put, oops, wrong button, what exponent do I put on 2 that will give me 8 as an answer, and the answer that is a 3. So that is the exponent that we're looking for. So what number can go on 2 that's going to give me 8? Alright, if you look at the top of page 403, it gives you some different ideas there as far as being able to write logarithms. And let's go ahead and jump into example 1, because the definition of logarithms can be used to solve equations here. So for example, example 1 part A says log with a base of x to 8 over 27 equals 3. So what that's saying is, what exponent can I put on x, which in this case 3, is going to give me 8 over 27. So what number cubed is going to give me 8 over 27? Well, if I just look at that, I can tell that it's going to have to be 2/3 cubed is going to give me 8 over 27. Now you can... Okay, let's look at part B here. We have log with a base 4, and we want to get x, and we have a 5/2. So again, in exponential form. Okay, so what do I do with that? 4 to the 5/2 power equals x. Well, let's go ahead and split this up using some of our old stuff. So we're going to write it as 4 to the 1/2 power to the 5th. Okay? And this means the square root of 4 to the 5th, so 2 to the 5th power equals 32. So 4 to the 5/2 power equals 32. So again, it's using lots of this old math stuff that you didn't think you would ever use in upper level math. And that is a cubed root of 7 equals x. So 49 to the x power equals the cubed root of 7. Okay, what do I do with that? Well, first of all, what I would do is I would change that cubed root of 7 to 1/3. Okay, and that leaves me kind of a messy thing. But what I remember is from the first section, 9.1, is that these two bases are the same, then my exponents are equal. So I'm going to change this to 7 squared. So 7 to the 2x equals 7 to the 1/3. So again, this is actually, let me not skip a step here. Let's write this as 7 squared for 49 to the x power. So 7 to the 2x equals 7 to the 1/3. Since my bases are the same, I can write that as 2x equals 1/3. My exponents have to be the same. X equals 1/3 over 2, or times 1/2 equals 1/6. So my x, this number is going to be 1/6. So 49 to the 1/6 power equals the cubed root of 7. So 1/6 power equals the cubed root of 7. Alright, let's continue on here. Okay, on some of the examples I just did, I had y equals the log of the base a of x. We're going to change that y to a function. So nothing's going to change. Even finding the answer, anything is not going to change. We're just going to use an f of x instead of a y. Top of page 406 says the points 1 over a, -1, 1, 0, and a1 are on the graph. If you were to draw this graph, there's 3 points that are already there for you. If a is greater than 1, which it has to be greater than 0, and it cannot be 1, but it can be between 0 and 1, and it can also be a number greater than 1, but it cannot be the number 1. So all that to say, if a is greater than 1, if that base is greater than 1, then f is increasing function, meaning it's going like that. If f is between 0 and 1, then it's a decreasing function. So if we've got our graph here, it's going to be decreasing. Alright, the y-axis is a vertical asymptote, always. And the domain is, so the x opportunities are between 0 and infinity, never negative. And the range is somewhere between negative infinity and positive infinity. That means the lowest point and the highest point are negative infinity and infinity. The y, the up and down, the vertical. So the left and right can't be any bigger than or any smaller than 0. In fact, it can't even be 0. Notice the little round parenthesis around the 0, meaning it cannot actually be 0. Alright, so example 2 says to graph the function, and we'll start on that on the next video.